So in this segment, we're going to give it the highlights of what the system requirement specification for our example project would look like. We'll go through each of the steps and just discuss them one at a time. So remember, this is the image-guided neurosurgery example. This is what the actual solution looks like. The surgeon is operating on a patient. They have a surgical tool, and when they touch on the patient, they can see the position of that pointer in the images that are acquired before. This is sort of a GPS system for surgery. It lets them navigate through the process. So we're going to flash back to a user needs discussion and ask ourselves, what is our neurosurgeon trying to do? The surgeon is trying to remove as much of the epileptogenic tissue as possible while avoiding functionally important zones and completing this procedure in the minimum amount of time possible. So we've seen this slide before, and as just like the second slide, this is what our user needs are. What would she like to be able to do in addition? She'd like to be able to see the location of her surgical tool on the images of the patient. This will eliminate the need to keep going back and forth to the wall to look at the images, and it will reduce the mental stress required to keep all the information in her head at all times. And maybe we'd like to be able to use functional images to define the zones to avoid. Remember my picture of the motor cortex that we showed about 3 segments ago. And finally, we'd like to create surgical plans ahead of time to guide the procedure so that we have plans drawn so that we can just go in the operating room and just follow the plans. So the first step in this process is to identify the usage scenarios. Who, what, where, and with what. Okay, so let's give examples of a couple of scenarios here. Now, these are, in the text, we give the full description, all the scenarios. Here, we're just going to give some examples in this presentation format. So scenario 1, the intended user is a neurosurgeon. The intended use to navigate during an epilepsy neurosurgery procedure. This means being able to see the position of the surgical pointer on the anatomical MRI images of the patient. So this is the crosshairs that we showed before. The intended use environment in the operating room using a touchscreen computer mounted at eye level. This is a scenario: who, what, where, and with what. Okay, so that is a scenario. Let's look at another scenario. This is scenario 4 in this design. The intended user is a neurologist. It's another kind of doctor that studies brain diseases. The intended use is to import surgical plans, creating external systems that define the surgical resection area for removing the target region. So for example, if this is the brain, we may have decided as part of our discovery phase that this is the part of the brain that needs to be removed. And in epilepsy, large chunks of brain get removed. To be able to create this drawing and import it into the navigation system so the surgeon can follow this plan during the procedure. The intended use environment, this is done in their office using a desktop PC. Again, who, what, where, and with what. These are the questions we have to answer. When we have this initial usage scenario, and remember, risk analysis are constant companion to this process, now we ask questions, what could go wrong here? Now, this is what they would like to be able to do. This is what our users need. But what risk do these needs entail? What do they create? So we perform an initial risk analysis here. So for usage scenario 4, the risk might be that the images and surgical plans for the wrong patients are imported accidentally or that they are imported incorrectly. And so what are risk control measurements? We could add a requirement that the patient's name is explicitly checked at each step in the process and that the patient's name appears on the screen at all times. And in fact, if you see a piece of software like this, the patient's name is always on the screen. We may be able to have to create screenshots of critical parts of the plan as checks so we can look them one next to each other. So the way these enter into the process is as additional non-functional requirements. That's the only way in. So the next step now is to identify the actual requirements. So when we design here, it's a solution, not a single piece of software. This is really a collection of tools. And not just a collection of tools, but a collection of tools plus user training plus documentation. The solution is the user plus the software. And so all of those things together form our solution. So here, what we'll end up designing is actually 3 pieces of software that communicate to achieve the tasks that we need them to achieve. So the non-functional requirements address safety, security, and regulatory issues. For example, radiology convention for images, the left-right business. And again, as Dr. Sarkar was mentioning, no user will specify this to a software engineer. It will be assumed. And this is a legacy standard that one needs to become aware of. And there are other legacy standards if you're replacing an existing system and the user interface looked in a certain way, red meant something and blue meant something, you want to, as much as possible, follow those conventions. Otherwise, you create hazards because the users are used to doing things in one certain way and you don't want to change them, even though you may think it looks better, because that's part of the issue here. We want to reduce risk. We want to ensure that the users are not confused. So the next step in identifying requirements, we may have to have performance and ease of use requirements for the software, and then we design a system in such a way, for example, this is a privacy issue, that all the patient data is removed from it once the surgical process is completed and stored only on centralized hospital infrastructure. That is a requirement to ensure data privacy and reduce risk. And we have to worry about cybersecurity. Our system should always require authentication and encryption to reduce the risk of unauthorized access to the data. Those are all things that come into the requirements. When we're done with our requirements, we go back to what we always go back to, risk management. So we do a risk analysis. Can the functionalities lead to harm? So let's take scenario one, mapping the position of the patient to the actual images, because this is part of the neuronavigation. If we have a bad mapping, we can have errors in the navigation, and so the user may specify the accuracy level as part of the niche finding process. We need to be less than 2 millimeters. So the risk management process here is that we have to add a step after the mapping and ask the user to confirm that the pointer location of the image corresponds accurately to physical location of the pointer. And this is important, as you will see when we discuss software workflows in the next section. You'll see a process that consists of 5 steps, and the first 2 are the actual functional steps. They do the actual thing we need to do. And the last 3 steps are risk management. Ensure that it's accurate. Ensure that the process was done correctly. Check, confirm, verify. All of those things are important, and the risk management process is a critical component in avoiding issues. So we have functionalities, and then those functionalities, we evaluate them for risk, and that risk analysis leads to more requirements as part of our risk management process. So from here, we can go through and create our intended user uses environment table. So this could be our intended users, the neurosurgeon and neurologist, the technologist, and the intended users. We're doing neuronavigation with anatomical data, neuronavigation with functional data, image data and transfer, and surgical plan import. Those may be all the uses. And then the user environments, physical environment location. We would have a touchscreen PC in the operating room and a desktop PC. The platform may always be Windows 10 or 11 by the time you finish listening to this class. The IT environment, we need to communicate with the PACS database to import images and annotations. And legacy, again, the radiology convention, and there may be other conventions that we have to follow. Once we have that, then we're now ready to take this scenario and to write the actual requirements, the things that the software must do. So let me give you an example of a functional requirement and an example of a non-functional requirement. So requirement 100 is always good to number the requirements because then you can trace back and forth. The system shall be able to successfully import images from a PACS server. PACS is the imaging database of a hospital. B, what's the traceability? Who needs this? It's driven by user B and C for intended use C, which in turn is needed for intended use A. Okay, you'll figure that out. Comments, the ability to obtain images from the PACS server is a critical component as these images are needed for neuronavigation in the clinical workflow. So what we must do, why are we doing this in terms of traceability, what drives this, and what is the rationale, sort of more English, more vocabulary-oriented sense, and less technical sense, why are we doing it as a big picture? Where does this fit in the big picture? So this is my example of a functional requirement. And then we have a non-functional requirement example. This could be 500. The system shall be able to notify the user if the correct position of the surgical tool is out of date, and we define out of date as more than 1 second old. This is a safety concern. It came from our risk analysis. So this is not tracing now to the needs of our user. It's traced to the risk analysis. Comments, we must ensure that the neurosurgeon is not given false information at any point in the surgery as to the position of her tools, because this leads to serious errors in the surgical procedure and harm to the patient. So you can imagine if that they feel that their pointer is at the wrong point in the image and they start cutting because they think they're far away and all of a sudden they're in a critical zone. This could lead to serious harm to the patient. So this concludes our discussion of the system's requirement specification, both in general and for this specific project, the Image-Guided Surgery project. In the next week, we'll pick up the story and we'll take these as inputs now, these requirements as input, and use them to create a software design which is the next step of the process. We will need to design our software so we can then go ahead and implement and test and get it all the way into the hands of our users. Thank you.